package delivery. Well, it's a great thing, but it sure can be a challenge to automate, especially for that last 50 feet. Well, Robert, Jaime, you guys are developing something to solve that problem. Why don't you tell us a little bit about Vault Robotics? We'll have a conversation about this challenge.
So Vault Robotics is a spinout from Princeton University, founded by myself, Robert, and Professor Jaime Fernández Fisac, Professor of Electrical Engineering. What we're doing is we're creating an autonomous robot that will address the last 50 feet of package delivery. So transporting packages autonomously, safely, and efficiently from the curbside to the front doorstep.
And so that is a huge challenge. Why hasn't it been dealt with heretofore?
There's multiple factors. I think it's not fair to say that it hasn't been attempted. There's been multiple attempts, especially in recent years, as robot autonomy has become more advanced and more capable. But ultimately, the problem has just many different prongs that need to be solved at once. And they involve the autonomy stack, but also they involve the hardware design. And part of the challenge that we think remains, in spite of efforts from the industry so far, is you need to get the package safely and reliably to a place where you can really drop it off so that the customer can pick it up potentially later when they get back home. And this is something that you can't do if your robot is essentially a locker on wheels, which is what most of the industry solutions have been so far. So that kind of solution can work if the person's going to be home and going to pick up the contents of their delivery immediately, but it's something that falls short of dropping off the package safely at their front step. Not to mention the fact that in reality, most of the time, these robots are not going to be able to just travel on a flat surface. They're going to need to hop over curbs, climb steps, and wheels alone are not going to cut it.
It also seems like you're taking an approach where you're augmenting the human.
So what we did is we created a robot that uses both legs and wheels, so it can move really quickly over flat surfaces, but also climb curbs and climb stairs like a human would be able to do. So we aren't looking to completely eliminate the human delivery driver. Instead, we're trying to make their lives easier, because the job of a delivery driver is very tough. They're working long hours, carrying heavy loads, and they have to do a lot of walking. So our approach is, hey, we can let the delivery driver stay in the van while our robot is the one that exits the van and goes and deposits the packages at the front doorstep and then comes back.
Another thing that seems unique is you guys are, even though you're pretty early in your stage of a company, you're working with industry standards. Bernd Grush, we were talking about the Urban Robotics Foundation. Maybe you want to talk to that and the importance of that.
Yeah, so we've taken a lot of lessons from the autonomous vehicle industry and how safety is really at the core of any autonomous system. What we're basically doing is we're creating a small autonomous vehicle that will travel partly on the road and partly in the last 50 feet, so on private property and on sidewalks. And so we're deploying a robot in public spaces, and there's a lot of challenges associated with that. We're in an environment with people, with animals, with property, so safety is absolutely critical for deployment. And we've been working closely with regulators, as you mentioned, like Bernd Grush, Urban Robotics Foundation, and also talking with people in the UPU Consultative Committee, Universal Postal Union, on regulations around data and handoff between robots and consumer.
Well, that's interesting. I didn't think of it when you were presenting that, but Universal, the Postal organization you just mentioned, do you foresee this being used by not only private carriers, but by public carriers?
Mm-hmm. Yeah, definitely. So package transport is something that's across many areas. There's like the companies you think of like Amazon, UPS, FedEx, but there's also the United States Postal Service and national postal carriers that are also transporting a lot of packages. So it's a problem between public and private.
Absolutely, and very much part of the idea here is to democratize access to efficient package delivery. So we don't want this to be, sort of a monopoly where only one particular company owns the entire stack by themselves. We think that ultimately, everyone should benefit from the advancements that we have in technology, and ultimately this also allows for better competition, and the customers will be the ones to gain at the end of it.
Well, that's interesting because the way you're deploying this with the truck and then the last 50 feet or whatever, conceivably, those devices going that last 50 feet might be different. So you'd probably want common data formats and so forth, right?
Oh, yeah, exactly. In automation, data is such a huge component. We're actually working with a consortium called the Katina Consortium that's working to create an end-to-end solution and really have comprehensive data collection all along the way in a way that's more modular. Creating that data backbone so we can integrate a lot of autonomous systems at every step of the delivery process, from line haul to in-warehouse sorting and to the last mile, last 50 feet.
And one of the things you brought up in your presentation, probably the most important thing, is that the number of packages that are being delivered today there's a lot of them, but there's going to be even more by 2030, right?
Yeah.
That's right.
Yep. So the last mile delivery market is increasing exponentially. And so we're seeing a doubling in the number of packages every 6 or so years. And to address that right now, delivery companies, they just have to hire more drivers and get more vehicles. And that's also just another point is the delivery is not constant throughout the year. During the winter holidays, the delivery demand surges. And so companies right now, what they're doing is they're hiring a bunch of people in October and then letting them all go early the following year. And so what's really needed in the industry is a flexible solution that can accommodate to those increasing demands, both in the market trend and during seasonal fluctuations. And so that's what we hope to address with Vault Robotics by automating that last mile of delivery.
Yeah, and by creating that open system, I could see where you might have robots with tracks on them deployed in certain places, maybe not manufactured by you, but someone else, right?
Definitely. So there's a whole varying range of terrain conditions. It could be sandy, gravelly, snowy, and also just pavement. And so there's going to have to be a lot of different robots to address those situations. And one thing that we're doing with our robot is creating it such that it's modular. So you could remove the legs and replace it with tracks, with wheels, to fit many different environmental conditions.
That said, I think it's also fair to tackle one problem at a time. Yeah. We're very likely not going to be deploying on snow or extremely challenging terrains first. Even if you're able to have initial robotic solutions that can help package delivery humans with, say, a third of the deliveries, 2/3 of the deliveries, that's already a huge help. And we think that there's going to be a lot of interest and there's a lot of value in being able to do that. And then gradually, you want to sort of get perhaps closer and closer to being able to help with all of the packages, but it's actually perfectly fine if you never get to 100%.
So tell us a little bit about the safety aspects of this.
Yes, this is something that we think about as something that is absolutely core to our technology. And this is that the robots, as they are shuttling packages back and forth, they're not only going to be hoping that their operation is safe, they're actually going to be proving in a meaningful way that their operation is safe. And they're going to be doing this multiple times per second. The way in which they do this is we run some pre-computations offline that allow the robot to come up with very good safety-preserving strategies for its motion. And then in real time, what the robot does is it simulates a batch of possible scenarios that it might encounter in terms of, is this person going to start running towards me? Is that dog going to suddenly run off leash? And it makes sure that at every moment in time, it has a good plan B that it knows it can call up on if the situation gets complicated. At the end of the day, there's always the option of racing all the way back to the van and hopping back onto safety.
Yeah, and safety enables efficiency.
At the end of the day, these technologies are not going to be viable unless the robot is able to make it to its destination and back to the van in a fairly quick and agile manner. We know that this is not possible to deploy unless it can do so in a way that is absolutely reliable and safe. Not only circumstantially safe, but certifiably safe in a way that the robot can communicate to people and that is perfectly transparent and understandable. And we think of this way of building public trust as ultimately being what enables an actual practical solution to the problem that we're trying to address.
There's certainly a lot of work to be done, and there's a lot more packages to be delivered, and it looks like you guys are on your way, so good luck.
Oh, thank you so much.
Thank you.